Let's talk chemistry with Pastor Dan. We're beginning a new concept looking at thermochemistry. Thermochemistry is defined as study or reaction that process require or produce energy, something that's going to put energy into things or take energy out of them. So, one of the very first things we have to look at in thermochemistry is what's called the first law of thermodynamics. It's one of the first laws that we're going to discuss. There is a second law that we talk possibly later. First law identifies that in the universe, energy cannot create or destroyed, but simply changed in form. By saying in the universe, we identify where it takes place. By saying the universe, it works everywhere, on the earth, outside the earth, all the way around, every place you go to, and it simply changed in forms. Now, in order to do energy, there's a couple more terms we need to know. First of all, work. Work is defined by a force applied through a given distance. And second, we have energy. Energy is defined as the ability to do work. Now, there are a total of 5 different types of energy or classes of energy that energy can be converted between. The first is mechanical. Mechanical is energy associated with movement. So any kind of movement, any kind of change of position, that's mechanical energy. Second is thermal, energy associated with vibration of particles. Remember we talked about before, talking about temperature. The more it vibrates, the greater the energy. The less it vibrates, the less the energy, all the way down to where it stops, and that's 0 Kelvin, where there's no motion at all. Electromagnetic is energy associated with moving electrons. That would either be light or that would be electricity. Okay, so those are 2 different ways we can have electromagnetic, either as light or electricity. Nuclear is defined energy associated with the splitting or combining of atoms. That's fission, fusion, those kinds of process, which will come later this year. And lastly, chemical, energy associated with the splitting or combining of bonds, things that make changes in the substance so they're not the same. So 5 types of energy associated up there. Going too fast, pause it, write them down. There we go. All right, now, let's take a scenario. Let's say we want to bake a cake. I'm going to postulate to you that there are 7 different steps, different energy forms to bake a cake. Now, this would be an awesome essay question. So anything that would work along those lines, good to go. So how would you bake a cake? Well, you can either use a box mix or you can do it from scratch. Either way, if you're using a box mix, you got to open the box up. You got to open the bag out. You got to dump it out. Throw eggs in it. Throw milk in it. Stir it up. If you're doing it from scratch, you're going to measure out exactly so much flour, put that in, so much baking soda, put that in, so much vanilla, put that in, put so much milk, stir it up, add the eggs, stir it up. All those, either way, would be mechanical because all to do with motion. Now, once you do that, you have to put it in the oven. To get the oven started, you have to turn it on. So that's either going to be electromagnetic or chemical. Electromagnetic, if it's electric range. Chemical, it's a gas stove. Now, once you put it in there, changes are going to begin. That gooey batter is going to become a nice fluffy cake. So that would be an example. Oh, I forgot thermal. We have to heat up the oven. Then we're going to bake the cake, and that would be chemical. Thermal, we're going to heat up because the oven itself isn't heated up. So we get it up to the temperature around 350 degrees, and then we have the chemical reaction taking place. So we get the carbon dioxide release. The cake rises, things along that line. Now, once we get a cake done, I don't know if you ever tried. I have before when I was in a hurry. If you try to ice a cake too quickly, what happens? All the icing runs off the side. So we have to let it cool down. So that would also be an example of thermal. Then we're going to ice the cake. We're going to cut the cake. We're going to serve the cake. You're going to take and put it into the cake, put it in your mouth, chew it up. All of those mechanical. And then you swallow it, goes in your stomach, breaks it down. Last step would be chemical. So those would be the 5 steps we go through to bake and eat a cake. Hopefully that makes sense. I could talk about how to get to school in the morning. I could talk about how you turn your computer on. All those things would work in a similar process. All right. Now, additional terms we look at. There's 2 things we can look at, temperature and heat. Temperature is defined as an internal measure of energy, okay? So when you're not feeling well, someone goes, wow, you have quite a heat? No, they say you have a temperature inside the system, energy inside. The other possibility is heat. Heat is external. So when you feel the sunshine outside, you feel the heat. You don't feel the temperature. You feel the heat that's inside of it. Now, units of temperature are either degrees Celsius or Kelvin. Remember, Kelvin is absolute scale. There's no degrees. And for heat, it's going to be either joules or calories. Now, there is one that people get confused by. They go, wait a minute, Mr. Fenner, I watched the news, and when talking about the weather, they talked about the temperature, and the temperature is outside. So isn't that messed up? So no, you got to think about how a meteorologist sees it. He's talking inside of the system of the weather. So the energy inside that system is the temperature. It is internal. Does that make sense? Hopefully it does. Now, some last couple more concepts we're looking at. Intensive properties, extensive properties. So an intensive property, nature of the substance, so they never change. Extensive properties determined by how much you have. So let's say I have these four qualities: density, length, mass, and volume. So intensive are properties determined by how much nature of the substance, they never change, they're always the same. Extensive properties determine how much is there. They can change. The more you have, the more you have. So let's start on the end here, volume. If I pour a glass of milk and then I put more glass in that milk, I'm changing the volume. I'm putting more in, I'm getting greater volume would be extensive. Mass, if I mass something, then I put more mass on, the mass goes up. So mass would also be extensive. Length, if I measure something and then I measure further, it gets farther. Length would also be extensive. Finally, density. Density of water is 1 gram per milliliter for water. If I take a cup or I take the ocean, pure water, 1 gram per milliliter. Always the same, doesn't matter how much it is. So an intensive property would be example of density. Okay, so intensive, extensive. Good. All right, 2 more concepts looking at chemical change, physical change. Chemical change, type of change where a new substance is formed. That's chemical. Physical change, type of change where no new substance is formed. That's a physical change. Let's show a demonstration I did here in class. So up the video. Okay, now this time we're going to look at a chemical and physical change and definitions again. Physical change, a change where no new substance is formed. Chemical change, substance change where a new substance is formed. I'm going to start with some sugar, some regular sugar. Take a small amount of the sugar right here, and I'm going to add it to some water. Now, as I put it in there, you can see the sugar is beginning to dissolve. So the sugar no longer looks the same as it used to look, and we're going to see a substance that is different than it was before. Now, is this a chemical or physical change? Substance was before sugar and water, now it's sugar water. If I'm really, really patient, I'll put this on the back sill in my room, let it sit there for 4 or 5 months, 6 months, eventually the water will evaporate, and we'll go for sugar. So nothing new is being formed. Now, on contrast with that, I can take some more of that sugar, right here, just put some sugar in this evaporating dish before, and I'm going to add a small amount of this white powder. Now this white powder is potassium chlorate. Now potassium chlorate is an oxidizer. An oxidizer means that when it's heated up, it will produce fire. So I'm just some potassium chlorate inside of there. And the way that I'm going to excite the sugar combo is I'm going to add a little sulfuric acid. Now sulfuric acid is a very, very strong acid. I always tease that I will inform the young men that take my daughter out that I have, and they'll never find the body. I just tease, I would never actually do that, so they think. All right, so right now, right inside there, we got the sugar and the potassium chlorate. I'm going to turn the hood on here because we're going to generate a gas that's slightly toxic, and we don't want that to get to us. All right, so if we're watching, small amount acid in it. Now, in the end there, we end up with a substance that nowhere looks like sugar anymore. So a new substance is definitely formed. This is an example of a chemical change. All right, great. There we go. So that's a chemical and physical change. Now, the last concept we're looking at then is exothermic and endothermic. Definition of exothermic, type of reaction where energy is released. So what we're saying here is it's going to get hot, not hotty, hot. And endothermic, type of reaction where energy is absorbed. Now, this is going to either get cold or it's going to require energy to start, okay? So let's see another demonstration set here. Welcome again to Let's Talk Chemistry with Pastor Dan. We're going to look at endothermic and exothermic reactions. We have two substances here. We have ammonium nitrate. Ammonium nitrate is a highly energetic substance. It's a substance that Timothy McVeigh used to make his bombs in Oklahoma, which is not good. Barium hydroxide. Barium hydroxide is a heavy metal, so we don't want to pour that down the drain. We take and put these two together, and I've got a little thermocouple here. Get a temperature, put inside. See the temperature is right about 25.5, 25.4 degrees Celsius. A little bit warmer than room temperature. I'm going to take and pour these two together. Now, as I pour these two together, I'm going to begin to agitate and react together. As it reacts up, you're going to start to see some clumping here. The clumping is a result of the formation of water and ammonia that's formed. So it does have a smell which you can't generate. And we can see that clumping action as it works inside of here. We react them together, keep them moving, keep it turning. In the process here, as I definitely get a lot of smell of the ammonia that's being formed. Okay, I'm going to take and put my thermocouple inside of it now, inside of here. You can see the temperature is dropping quite quickly as this reaction is endothermic. Energy is being absorbed, so it's dropping the temperature quite well. I will take care of that later. Now, the next reaction we're going to do here is we're going to take a water bottle. And into this water bottle, I'm going to add a little methanol. Now, methanol is an alcohol. It's highly flammable. Put a little bit in there. We don't need much. And I'm going to take and get it to equilibrium. The way that I'm going to do is I'm going to spin around inside of here. And that causes the alcohol to come to an even point of reaction. I'm going to pour off the excess liquid because we don't want, liquids don't burn, it's the vapors that burn. That's why I brought it to equilibrium. Okay, I'm going to take, be right back. Take one last match here. I'm going to take, I had some issues here, so I'm going to move this forward a little bit there. Now this reaction, there we go, is referred to as turbine. Now, we do the thermocouple on the end in here, and you can see the temperature is rising quite quickly. That is an exothermic reaction. It's a combustion reaction. Those are the example of those two types. All right, exothermic gets hot. Endothermic absorbs or requires energy. We're good. Thanks. All right, so that's the end of the notes. Hopefully that wasn't too bad. Take care. God bless. Have a good night.